Here we go. So now I've got two vectors that are in position vector form, and you're probably looking at this and saying, well, how did he get to there? And what does that even mean? This form here that I'm circling represents what I call component vector form. Okay? The I and the J are going to represent unit vectors that only go in the x and y direction. So I represents the unit vector in the x direction, and J the unit vector in the y direction. Okay? And when we talk about unit vectors in a sec, that'll make more sense, I think. So in order to convert this to this, you simply take your 2 and attach it to the I. So it's 2 times I. And your 3, which is your y component, and attach it to the j. And then you keep the signs the same. So over here we had 3 and negative 4, so you have 3i minus 4j. So now you've written it in component vector form. Okay? Now when I want to go and add vectors, we tend to do it only from component vector form. So 2 plus 3i plus 3 plus a negative 4j, leaving you with 5i minus j. And now you have what v plus w equals. Okay? So if you want to look and see what v plus w should look like, it's going to be represented by this blue guy. We have v here, and we have w here. Okay? And then the blue represents the resulting vector of that. All right? In order to do the opposite, you need to first create negative w and do the exact same thing that we did in slide 1. Or I believe it's slide 1, excuse me. Now, to do mathematically what we just did in the last slide, again, we're going to take our v, which was 3, I believe. Oh, no, excuse me, 2, minus our w. And our w is, let me look here. 1, 2, 3, 4. Come on. 4. Okay, so we have our x component, x1, x2, y1, y2, and so we're going to go 2 minus 3, and then 3 minus a negative 4j. So you have 2 minus 3i and 3 minus negative 4j for negative I plus 7j. So in much the same way, for adding, we're subtracting there.